Hey guys, this is Doug at Bluecraft. I'd like to give you a quick overview of the coordinate system used in MachUp. It can be a little bit counterintuitive to the coordinate systems that most people are used to using for aircraft design. So I'm just going to add in a wing here so we have something to look at as we talk through this. Now in MachUp, the red axis is the x-axis, the green is the y-axis, and the blue is the z-axis. So you'll notice that the x-axis is actually pointing forward from the aircraft, y is out the right wing, and z is down. This is a little bit different than conventional aerodynamic coordinates, but it turns out to be really useful when we move to the next step, which is understanding the flight mechanics, the forces and moments on this aircraft. So that's why we've chosen to just start in this coordinate system so that you don't have to do a transformation later on. So for example, I'm going to add a control surface, and we'll hook this up to the aileron. And now if I give that 20 degrees of deflection, you can see that the right aileron is deflected down, the left aileron is deflected up. Now, conventional flap deflections are generally positive when a flap or a control surface is deflected down. So you see that with positive aileron deflection, the flap on the right hand side is deflected down, and on the left hand side is deflected up. Now if we run a quick forces and moments calculation on this, we get our forces and moments here, just a summary on the screen. Lift coefficient, drag coefficient. C sub y now is our coefficient in the y direction, or our side force coefficient. And then we have three moment coefficients down here at the bottom, CL, CM, and CN. Now, L, M, and N are an alphabetic triad that correspond with X, Y, and Z. And so CL is the rolling moment, or the moment about the x-axis, CM is the moment about the y-axis, and CN is the moment about the z-axis. Now if we had stayed with aerodynamic coordinate systems, then the direction of these are not always intuitive. But in this coordinate system, flight mechanics coordinate system, these are very intuitive, and they all follow simply the right-hand rule. So our rolling moment is negative when the aircraft wants to roll to the left. And you'll see that with positive aileron deflection, this aircraft wants to roll to the left. We're going to have an increase in lift on this side, decrease in lift on this side, which causes a negative rolling moment. So if you put your thumb along the x-axis here, then according to the right-hand rule, you can see that that's a negative rolling moment. Our pitching moment, C sub m, is here about the y-axis, and that is naturally positive, nose up, and naturally negative, nose down. And then our yawing moment is, if you put your thumb in the direction of the z-axis here, you can see that a yawing moment would be yawing us, a positive yawing moment would be yawing us to the right, and a negative yawing moment would yaw us to the left. So I just wanted to quickly explain this coordinate system and how it aligns so well with these forces and moments that everything follows the right-hand rule, and that's the reason that we've chosen this flight mechanics coordinate system. So I hope that video has been helpful. Leave us a message if you have any questions. Thanks.